Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss continuity and differentiability. We are discussing the chapter continuity and differentiability. In this chapter, we are discussing exercise 5.8 sums. In this chapter, we are discussing exercise 5.8 sums. Page number 186. All of you open the textbook, page number 186. Okay, my dear children, are you ready to listen the class? Yes. In the previous class, we have discussed question number 1 and question number 2 in this exercise. So, we are going to start question number 3 today. Okay, my dear children, see the question number 3. If the function f is defined from closed interval -5, 5 to capital letter R, that is real numbers, is a differentiable function, and if f dash of x does not vanish anywhere, then prove that f of -5 is not equal to f of 5. Understood the question, my dear children? What is the function here? F. And what is given here? F is differentiable. F is differentiable function, and f dash of x does not vanish, means f dash of x is not equal to 0, does not equal to 0, it is not equal to 0 anywhere. Then we have to prove that f of -5 is not equal to f of 5. Okay, my dear children, now come to the solution part. For Rolle's theorem, what are the conditions should be satisfied by the function f? F should be continuous on closed interval a comma b. F is differentiable on open interval a comma b, and f of a is equal to f of b. These three conditions should be satisfied by f. Then f dash of c is equal to 0 for c belongs to open interval a comma b. Do you remember these three conditions, my dear children, for Rolle's theorem? Right. But we are given that f is continuous and differentiable. This word is not given in the question, but we know that every differentiable function is continuous. Every differentiable function is continuous. This concept was learnt in exercise 5.2. Once recall that previous knowledge, my dear children. Okay, every differentiable function is continuous. Therefore, f is automatically it is a continuous function and a differentiable function. But this condition is not satisfied. F dash of x is not equal to 0. Then this third condition also not satisfied by f. This implies f of a is not equal to f of b. That is f of -5. A means here -5. B means 5. That is f of -5 is not equal to f of 5. Hence proved. Understood, my dear children? Right. Now come to the question number 4. Question number 4. Verify mean value theorem. Verify mean value theorem. If f of x is equal to x square minus 4x minus 3 in the interval, closed interval a comma b, where a is equal to 1 and b is equal to 4. Understood this question, my dear children? This question is the same as that of question number 1. We had to verify, but that first question is based on Rolle's theorem, whereas this question is based on the mean value theorem. Okay, my dear children, we follow the same procedure as we followed for the question number 1. Okay, my dear children? Right. Come to the solution part. What is the given function? F of x. So we wrote here, given f of x is equal to x square minus 4x minus 3 on interval 1, 4. Understood this step, my dear children? Right. If you observe this function f, which type of function it is? Yes, it is a polynomial function in x. Here f is a polynomial function in x. Understood this step, my children? Understood this sentence? Right. We know that every polynomial function is continuous and differentiable on any interval. You know this point also. Every polynomial function is continuous and also differentiable on any interval. We have discussed this point before starting the sums in the exercise 1.8. Before starting this exercise sums, we have discussed this point also, my dear children. Do you remember that one? Yes. Now let us take f of x, x square minus 4x minus 3. Now we are finding the differentiation of this function. F dash of x is equal to, what is the derivative of x square? 2x. What is the derivative of minus 4x? Minus 4. What is the derivative of minus 3? 0, because it is a constant. Understood this step, my children? We have found here differentiation of f of x. Then we got f dash of x is equal to 2x minus 4. Understood this step, my children? Right. The conditions of mean value theorem are satisfied. What are the conditions of mean value theorem? The function f should be continuous function, f should be differentiable on the interval. Okay, my dear children? So the two conditions are satisfied, but in the case of Rolle's theorem, three conditions should be satisfied, whereas in the case of mean value theorem, two conditions are enough. Okay, my children? So the two conditions are satisfied. Then there exists at least one point C belongs to open interval 1, 4, such that f dash of c is equal to f of 4 minus f of 1 by 4 minus 1. Understood this step, my children? Right. This implies f dash of c means 2c minus 4. We have already found f dash of x. In that function, substitute x is equal to c. Then we get this LHS part. Understood this LHS part, my children? Right. Is equal to, we have to find f of 4. In the function f of x, substitute x is equal to 4. Then we get these three terms, my children. 4 whole square minus 4 into 4 minus 3. Understood? This is f of 4 value minus f of 1. F of 1 means in the function f of x, substitute x is equal to 1. Then we get these three terms, my children. That is 1 whole square minus 4 into 1 minus 3. Understood this second part, my children? Whole divided by 4 minus 1. What will you get? 3. Understood this step, my children? Right. This implies 2c minus 4. We wrote LHS as it is equal to, in RHS, in the numerator, we are simplifying this first term. What will you get here? 16 minus 4 4s are 16. So these two terms gets cancelled. What will be the term left here? Minus 3. So I wrote here. Understood this first term, my children? Right. Minus here 1 square 1 minus 4 1s are 4. What will you get here? 1 minus 4 minus 3. Yes, minus 3. What will you get? Minus 3 minus 3 minus 6. Understood this second term, my children? By simplifying these three terms, we will get finally minus 6. Understood this second term, my children? In the numerator, right, divided by 3. Understood this step, my children? Right. This implies 2c minus 4 is equal to, in the numerator, minus 3 minus of minus 6. What will you get here? Plus 6. So minus 3 plus 6. What will be the answer? 3. Isn't it or not, my children? Yes. By we write a denominator as it is 3. Understood this step, my children? Right. This implies 2c minus 4 is equal to, we wrote LHS as it is equal to Come to RHS 3 by 3. 3 gets cancelled. 1 will be left. Understood this step, my children? Right. This implies 2C is equal to, we are moving -4 to RHS. Then it becomes plus 4. So 1 plus 4. Understood this step, my children? Right. This implies 2C is equal to, what is the value of 1 plus 4? 5. Understood this step, my children? Right. This implies C is equal to, we are sending 2 to RHS. Then it becomes by 2. So 5 by 2. If you observe the value of this C, it is lying between 1 comma 4. It belongs to 5 by 2 belongs to the open interval 1 comma 4. Understood, my dear children? Right. Now come to the question number 5. Verify mean value theorem. If f of x is equal to x cube minus 5x square minus 3x in interval a comma b, where a is equal to 1 and b is equal to 3. Understood this question, my dear children? We have to verify mean value theorem for this function. Means we had find the value of c. Okay, my dear children? Same as that of question number 1. But that question is based on Rolle's theorem. Here the question is based on mean value theorem. Okay, my dear children? Find all c belongs to closed interval 1 comma 3 for which f dash of c is equal to 0. We have to find the values of c in this closed interval 1 comma 3 so that f dash of c is equal to 0. Okay, my dear children? Right. Now come to the solution part. What is the given function f of x? So without this step, given f of x is equal to x cube minus 5x square minus 3x on the interval 1 comma 3. Okay, my children, understood this sentence? Right. If you observe this given function, it is a polynomial function. Here f is a polynomial function in x. And we know that every polynomial function is continuous and differentiable on any interval. Okay, my children? Same as the previous question, it is a polynomial function. So it is continuous and also differentiable. Therefore, here f is a continuous function as well as differentiable. Here the conditions of MVT. MVT stands for mean value theorem. The conditions of mean value theorem are satisfied. Isn't it or not, my dear children? What are the conditions of mean value theorem? F must be continuous function. It is satisfied. F must be differentiable function. That condition also satisfied. Isn't it or not, my dear children? Right. Then there exists at least one c belongs to open interval 1 comma 3 such that f dash of c is equal to f of b minus f of a by b minus a. Do you remember this condition, my dear children, of mean value theorem? Right. Now in LHS f dash of c is there. To find f dash of c in rough work, I am finding f dash of x first. So f of x is equal to x cube minus 5x square minus 3x is given. Now we are finding its derivative. So f dash of x is equal to, what is the derivative of x cube? 3x square. Understood this first term, my dear children? Right. Minus, what is the derivative of this second term? 5 into, what is derivative of x square? 2x. 5 into 2x. What will you get here? Minus 10x. Understood, my dear children, the second term? Right. Minus derivative of 3x. 3 is numerical coefficient. So derivative of x is 1. So 3 into 1. What will you get here? 3 only. Understood this third term, my dear children? Right. So f dash of x is equal to 3x square minus 10x minus 3. Okay, my dear children? In this f dash of x, we are substituting x is equal to c. Then we get f dash of c. Okay, my dear children? Then what will you get here? 3c square minus 10c minus 3. Understood this LHS part, my dear children? Right. Is equal to, in the numerator, first term is f of b. F of b means in the function f of x. substitute f of x is equal to 3 because here a is equal to 1 and b is equal to 3. So we are substituting x is equal to 3 in the given function f of x. Then what will you get this first term? 3 cube minus 5 into 3 square minus 3 into 3. Okay, my children, in this function we are substituting x is equal to 3. Understood this first term, my children? Right, minus we have to find f of a. In this function f of x we have to substitute x is equal to 1. Here a means 1. So 1 cube minus 5 into 1 square minus 3 into 1. Understood this second term, my children? Right. Whole divided by b minus a. 3 minus 1. Understood this denominator part, my children? Right. This understood this step, my children? Right. This implies I wrote LHS part as it is equal to, if you simplify this first term, finally what will you get here? Minus 27 minus, by simplifying these three terms, what will you get here? Finally minus 7. Do that calculation part in rough work. Then you get here first term is minus 27 and here second term is minus 7. Will you do that rough work? Will you do that calculations, my dear children? Right. Whole divided by 3 minus 1, what will you get in the denominator? 2. Understood this step, my dear children? Right. This implies I wrote LHS as it is equal to, what will you get in the numerator? Minus 27 minus of minus, what will you get? Plus 7. So minus 27 plus 7. Finally, what will you get here? Minus 20 in the numerator. Understood this numerator part, my dear children? Right. By 2. Understood this step, my dear children? Right. This implies 3c square minus 10c minus 3 is equal to 2 1s are 2 10s are. So minus 10. Understood this RHS part, my dear children? Right. This implies 3c square minus 10c. If you are bringing minus 10 to LHS, it becomes plus 10. So plus 10 minus 3, what will you get here? Plus 7 is equal to 0. So finally we get a quadratic equation in C. Okay, my children, we have to solve this quadratic equation for finding the values of C. Okay, my children? Right. Now we are solving the quadratic equation by using splitting the middle term method. We are factorizing that quadratic polynomial in LHS by using the splitting the middle term method. Okay, my children? This implies 3c square. We can split middle term, minus 10c is there. We can split as minus 3c minus 7c. If you simplify these two terms, what will you get finally? Again minus 10c. So we splitted minus 10c as minus 3c minus 7c. Understood these two terms, my dear children? Right. Plus 7. We wrote last term as it is equal to 0. Understood this step, my dear children? Right. This implies here from the first two terms 3c is a common factor. We can take it out. 3c is a common factor. Then what will you get here? C minus here 1. Okay, my dear children? Understood this first term, my dear children? Right. From these last two terms we can take a minus 7 as common factor. Minus 7 is a common factor. So we are taking out that common factor minus 7. Then what will you get in this brackets? C minus 1. Understood this second term, my dear children? Is equal to 0. Understood this step, my dear children? Right. This implies again here this is the first term, this is the second term. Only two terms are there. From these two terms, c minus 1 is a common factor. We can take it out. C minus 1 is a common factor. Then what are the terms left here? 3c minus 7. We get 3c minus 7 in this brackets. Understood this step, my children? Is equal to 0. Understood this step, my children? Right. This implies c minus 1 is equal to 0. 3c minus 7 is equal to 0. Understood these two steps, my children? Right. This implies c is equal to 1. Understood this step, my children? Right. This implies this side 3c is equal to, if we are sending minus 7 to RHS, it becomes plus 7. So this implies 3c is equal to 7. Understood this step, my children? Right. This implies c is equal to 7 by 3. Understood this step, my children? Right. So what are the values of c here? 1 comma 7 by 3. 1 comma 7 by 3. But here 1 belongs to that closed interval 1 comma 3. It should not be included, that number. This number should not be there in the given interval. So c is equal to 7 by 3. It lies in the open interval 1 comma 3. We got the point at one point c, that value is 7 by 3 in the open interval 1 comma 3. Understood the question, my dear children? Understood? Right. Now come to the question number 6. Question number 6. In this question number, there are 3 parts are there. There are 3 parts. Here I am explaining first part of this question. You try yourself the remaining 2 parts of this question. Will you try yourself the 2 parts of this question, my dear children? Right. Examine the applicability of mean value theorem for the function f of x is equal to step x. This is also called as greatest integer function for x belongs to closed interval 5 comma 9. For the same function we have examined for the applicability of Rolle's theorem. Now we are examining the applicability of mean value theorem for this function. Understood this question, my dear children? Right. Come to the solution part. We wrote the given function. What is the given function here? F of x is equal to step x comma x belongs to closed interval 5 comma 9. Understood this step, my dear children? Right. If you observe the given function, what type of function it is? It is a greatest integer function. Here f is a greatest integer function. Right. Understood this step, my dear children? Right. We know that the greatest integer function is continuous only in the interval n comma n plus 1, where n belongs to z. Do you remember this point, my dear children? We have discussed this point in the concepts of this exercise 5.8. The greatest integer function is continuous only in this interval n comma n plus 1, where n belongs to z. These 2 numbers should be successive consecutive integers. But if you observe these numbers, they are not consecutive numbers. Therefore, f is not continuous in the interval 5 comma 9. Understood this step, my dear children? Right. Therefore, the conditions of mean value, MVT stands for mean value theorem, are not satisfied here. Do you remember the conditions of mean value theorem, my dear children? Tell me, what are the conditions of mean value theorem? First condition is the function f should be continuous in the interval. And what is the second condition? F should be differentiable in the open interval. Okay, my dear children. But here the first condition itself not satisfied. Therefore, we conclude that mean value theorem is not applicable for the given function f. Understood, my dear children? Now do the remaining 2 parts. Do the remaining 2 questions in the Roman number 6. Will you try yourself, my dear children? Will you try yourself the 2 questions in this Roman number 6, my dear children? Right.